Okay, guys, so let's start our journey. Before that, we will do some recap of SOM, recap of strength of material. So, guys, first thing, can anybody answer why do we study SOM, strength of material? Why do we study strength of material? Can anyone answer? Why do we study strength of material? Sahil, why do we study strength of material? Someone where? We want at what extent we can apply load so material do not fail. Yes. It explains the stresses, strain, breaks, fractures, and the different types that will be developed in a material to understand the behavior of materials under different loading. Good. Yeah, to know why, where, and which material to use. Okay, material selection. To understand the mechanics of material upon application of load. Okay, yeah, so these answers are some extent correct. So basically what I call strength of material is what is one of the basic approach to analyze a mechanical design. So whenever people design a system, right, it need to be analyzed for what given load, for given goals. Okay, clear? So strength of material is one of the fundamental approach by which people can analyze a system कि this will sustain this much load under this kind of loading. Okay, clear? So the whole idea of SOM is to study simple approaches like if you take your aircraft wing, right? If you take this aircraft, okay? Now tell me guys, how we can idealize our aircraft wing to know broadly it can sustain that much particular load under bending, torsion, or shear. We can idealize how. If you take the whole aircraft, how you will idealize? And this one question is asked in many interview. Is it cantilever? See how lift will be acting. Is it cantilever? If you idealize the whole aircraft, is it cantilever? And where your weight? This one mistake done by many people. If you go if you go for interview in HL or in DRDO or in ISRO, they will ask you idealize a complicated or a flight vehicle structure in a simple. So now tell me what kind of idealization you will do for this. Is it a cantilever or something else? If you take the whole aircraft from front view, so overhanging beam or what you can tell in other way, is it overhanging? Is it overhanging? It can be idealized at what? Simply support beam. Clear? So if you take an aircraft with both the wings, it can be idealized as simply support beam. Your lift is acting as what? People idealized, though the lift distribution not be uniform, but people will consider as a uniform distribution, and it will act as a support. Okay, what is the load? Weight, where the entire weight of the aircraft acts, it acts on fuselage, right? Because CG will lie on symmetric line, right? Clear? So this idealization is clear, right? So if by taking this simple idealization, why it is not simply support? What is the simply support condition? Okay, so simply support, right? This is a simply support beam. Now you reverse it. You reverse it. You know buoyancy. If you take water, in water there is a boat. So why boat is floating? Why boat is floating? Due to buoyancy force, right? Same way, why aircraft is in air? Water is acting. Water is force due to water is acting on it, right? Buoyancy force, right? So buoyancy is a supporting force, right? So how you will idealize? It's a simply support, right? The support is throughout, right? The support is throughout, right? And it is due to what? Buoyancy force, right? And weight is acting what? Either you can say the weight is UDL, or you can consider as a point load also, right? At the centroid. Okay, so same way you can see this lift is what? Supporting force. And what is the point load, guys? What is the point load in case of aircraft? The total weight of aircraft, right? The total weight of the aircraft will be considered at what? This symmetry, right? So in the simple way, we can idealize the whole aircraft under lift and the total weight as what? What kind of beam? See, when we use overhanging beam word, when you have multiple unknown reaction, right? Mr. Shivendra, right? Somebody told overhanging, right? But here already lift is known, right? And weight is known. So this can be idealized as a simply support beam. Clear? Is this point clear? Everybody, why the if you take the whole aircraft from front view, it should be idealized as a simply support beam. Now, guys, look here. If you take the single wing, if you take the single wing, okay, then how it will be idealized? You can take lift is acting upward, and usually the total weight of wing and engine and everything, people can tell it is acting at the tip, right? So what is this? It's a cantilever beam. Okay, so you know all these idealization we are doing what? On what concepts? On the concepts based on strength of material, right? Based on like beam theory, and then you have torsion, you have axially loaded structure, right? All this. So in brief, we can analyze any complicated mechanical system by idealizing in a simple structure using strength of material basics. Okay, so strength of material is very important in any mechanical design to analyze, okay, that structure at preliminary stress, which where we use this idealization and all. Can anyone tell? There is a preliminary design, right? In design also there are different phases. Yes, preliminary design, detailed design, right? So in preliminary design, Sahil, you will be more aware, right? Because in UK and all, they do study based on all practical things, right? So in preliminary design, they will give you a project or a particular design, and you have to idealize, and then you have to solve it. Okay. Now, guys, what they do, always in aircraft industry, people use what legacy loads. Are you guys aware of legacy loads? They will use the previous aircraft's load and they will apply on new design, right? And then they will check those loads are sustained or not, right? Now, what is the parameter, or actually what people find always? Can anyone tell? In the end, in paper, what is written for any design? In design, you call certification. What is the finally written for any particular components or any structure? What actually written? Let's take static loads. What people write? Hmm? On what basis people say structure is safe? No, airworthiness is there, but what on what basis people say structure is safe under this much load? Yeah, maximum load taken by design, FOS, etc. Exactly. So, guys, always this is very important. What? This part. Factor of safety, reserve factor, and MS, margin of safety. So, what is the factor of safety, guys? This is again frequently asked question in interviews. If you go interview for structure related job, what is the factor of safety? People are not aware. Even they have read complete. It's not necessary ultimate load by maximum load. It's not that way. Factor of safety is always, guys, it's allowable by applied. So what it means? Which should be more? Allowable should be more or applied should be more? No, Abhishek. We don't define like ultimate limit. It's simple. No, Ashish, you are reverse. Factor of safety is always allowable by applied. Now, allowable can be what? It can be load or it can be stress. Same way, applied also can be load or it can be stress. Clear? Okay. So, if your allowable is load, then applied should be also load. If your allowable is stress, your applied should be stress. Guys, don't do this mistake while finding a factor of safety. One is load and another is what? What mistake people do? They will use allowable, stress, and then they will divide by what? Applied load. Or you can say max applied load. So this kind of mistake don't do. If you are using allowable as a stress, then applied should be also stress. Okay, so this is what factor of safety. In some organization, this same factor of safety, this same factor of safety is also known as what? Reserve factor. It is also known as reserve factor, RF. Okay. Now, factor of safety, tell me guys, is it less than 1 or greater than 1? What it is, less than 1 or greater than 1? Yeah, it's a dimensional less. It should be always greater than 1. Okay, for any safe design, factor of safety must be greater than 1. Same, your RF or factor of safety must be greater than 1. Okay, now guys, I'm asking one thing. What is the factor of safety in the range of factor of safety for aircraft structures or aerospace structure? What is the factor of safety? What is the factor of safety? Hmm? Okay, 1.5. Is it 1.5? It's close to 1.2. Factor of safety is close to 1.2. Okay, it should not be more. Why it should not be more? Why it is so close to 1? Why it is so close to 1 in aircraft industry or in aircraft or aerospace structure? Factor of safety is why so less? Yeah, money is the problem. People have so much of money. Do you think money is a problem? Weight is a problem. You cannot easily fly with the high weight. It's not about composite pragati. Earlier, all aircrafts were aluminum alloy, even metal. You cannot allow more factor of safety in aircraft. It's not just manufacturing cost. It's tough to fly efficiently if there is a more weight. Okay, so earlier the advancement was slowly happens, right? So always in aircraft, aerospace structure, weight is a constant. You cannot have high weight structure. Okay, so it need to be thin wall structure, and again factor of safety will be close to 1. There are certain reason. One, of course, manufacturing cost, or you can say material cost, because you cannot use, right, steel, right? Everywhere you have to use aluminum alloy or the high strength material, right? So in aircraft industry, we will discuss in tomorrow's class. There are two important factors we will discuss, not today. Yeah, so you guys understood what is the factor of safety, everybody? So always in the certification we write what factor of safety or reserve factor. Okay. Now some company use MS. What is the MS? Can anyone tell? MS or MOS? What is the MS or MOS? It's a margin of safety. It is what? Margin of safety. So margin of safety formula is what? It is always FOS or RF minus 1. So what it mean? What should be the margin of safety for any safe design? MS should be what? It should be always greater than what? 1. Is it 1? MOS should be always greater than what? 0. So that is what the criteria. It should be always greater than 0. It can be zero point 0.2, it can be zero point 0.5, but it cannot be high also. If margin of safety is high, then what people do? Can anyone tell? If the margin of safety is high in detailed design phase, what people do, Sahil? They will try to put what? Less thickness, right? They will try to optimize the structure for what? Weight saving. Yes or no? So always we try to keep positive margin, but healthy margin, not too what you can say, that side, what we call it, mm, over what word we use? Mm, okay, I'm not getting that word. Not buffed. We say this side conservative. We can't be too conservative. Okay, you need to be have healthy margin, but not so conservative. Okay, but anyway, majority of the engineering designs are conservative, right? Why, Sahil? Majority of the engineering designs are conservative. Ganesh, why? Pragati, why? Dine, Pranita, why majority of the engineering designs are conservative? Not about loss. It's not about loss. Why? No, majority of the engineering designs are conservative because we do lot of approximation, right? Lot of approximations we do, okay, while design. And which side you will do approximation side? We will do conservative side. Always what engineers try to do, what is the stress people write in general? Simplest formula of stress is what? So P by A, right? It's the simplest formula, right? So engineers always try to do sigma equal to P by A, but in actuality it's not always P by A, right? It depends on different loads, right? It depends on many other conditions, so we do lot of approximation. So majority of the time engineering designs are conservative. Okay, now guys, we were on factor of safety, right? So what is the factor of safety for mechanical designs? In aircraft design we have seen factor of safety is close to 1.2. What is the factor of safety for mechanical designs? So guys, clear? What is the factor of safety for mechanical design? It can go up to 10. Okay. Nowadays in mechanical design also, right? Do you think in automotive, you guys have seen ambassador car and you guys have seen Maruti car? Anybody is there from Kolkata, right? See the difference in design, right? Ambassador car and Maruti car, right? Assis, you know, you are well aware, right? Hind Motor. Now it's a junk company, right? No more. So you cannot have high weight structure. Okay. Now you guys can see everywhere people use as best materials and as less weight, right? In any design. So factor of safety, right? They are launching new version. Assis, are they starting in motor again? Or is it? That's good thing. Okay. So factor of safety in mechanical design, it can be up to 10. Okay. Now, what is the factor of safety for civil? Any civil engineer here? I think there are one or two civil guys joined IGC. Is there anyone today in today's class? What is the factor of safety in civil structure? What is the factor of safety? If a fort is designed or a building is designed, it need to last for what? For years, right? 50 to 100 years, right? So for civil, design, factor of safety can be up to 100. So Rahul, it is not for mechanical design, only for civil design. Mainly, you guys can see this of bridges and all. Okay, the factor of safety will be very high, and it can be in terms of hundreds. Okay, so that is about factor of safety. Now guys, you know about this enough, right? About this margin of safety, factor of safety, reserve factor. Now let's talk few more things. So what is the difference between bar and rod? You guys have learned, right? Axially loaded member. So what is the difference between bar? So bar can be of any cross section, rod is of circular cross section. Very good. Now tell me, what is the difference between bar, shaft and beam? What is the difference between bar when we call a slender structure bar, when we call a same slender structure shaft, and when we call same slender structure a beam? Can anyone tell? So these three depends on defined based on what? Everyone. Bar, shaft, and beam. These defined based on what? Types of load they bear, right? Types of load they subjected, right? Now bar can what carry? Bar can carry only axial axial load. Okay. If it is known as bar, then what we call it is subjected to axial load. What about shaft? Shaft is subjected to what? Torsional load. Or beam when your, yeah, I will talk about that. What kind of structure? If your structure is subjected to transverse load, transverse load, then it is known as beam. Now, what kind of structure can be bar, shaft, or beam? We call what? A slender prismatic structure, right? What is a slender prismatic structure? Can anyone tell? What is a slender prismatic structure? Hmm? We need to have a long structure, right? Slender means the length is high compared to other dimension. And prismatic means what? Can anyone tell what is the meaning of prismatic? The cross section is uniform and material is also uniform, and there is no impurity of the material. What is the prismatic structure? Cross section remains same, material is uniform, and there is no impurity of the material, right? So that is what prismatic structure. Slender means it's a long structure. So the same slender prismatic structure is known as bar if it is axially loaded. Okay, and if it is loaded with torsional load, so usually double arrow, right? We denote by torsion by double arrow. And if it is subjected to transverse load, either point load or UDL, it is known as what? Beam. So guys, is it clear now? What is the difference between beam, shaft, bar? Now in the practical case, tell me guys, will that structure subjected to different load at different time? In a practical structure, the same structure will be subjected to all kind of load. It depends how the load is applied. At the same time, it can undergo uh, bending, it undergo twist, or it may elongate along axial direction, right? Clear now? So that's why there is something called, guys, combined loading. Have you guys read about combined loading in SOM? Combined loading, have you guys read about that combined loading? Right, you guys all have read about combined loading, different type of load at the same time, bending, torsion, axial, right? So that is what combined loading. Now guys, I want next thing, what is the difference between bending moment and torsion? What is the difference between? Can anybody tell what is the difference between bending moment and torsion? No, that is what twisting moment. Torsion is twisting. Basically, both are what? Can anyone tell both are what? When both are produced, when this bending moment and torsion is produced, both are what? Both are couple, right? You guys have heard about the name called couple, right? Both are moment. Both are known as couple. When these are produced due to eccentricity of the load, right? When these are produced due to eccentricity of the load, what I mean, when you will have eccentricity, guys, due to eccentricity of the load, these are produced, right? Now guys, what is the difference between bending moment and, yes, uh, uh, bending moment is about lateral axis. Okay, that's one good thing. And what about torsion? What is basic difference between uh, both are couple, both are moment, and both are produced due to eccentricity of the loads? Now what is the actual difference? Okay, let me draw one beam. Okay, you guys will understand with that way. You guys must know what actual difference between bending moment and this torsion. I have a circular beam. Okay, now guys, the cross section of the beam is given by this. Okay, so this is what axis of the beam, right? It is longitudinal axis, right? Yes, I will come to your point, Abhishek, you are aware of that. Okay, so this is what longitudinal axis, and you will have cross sectional axis, right? You will have cross sectional axis. Okay, let me draw cross sectional axis. So right now, you guys can consider this is x, y, and z, right? So guys, now I am applying three different moment, right? Okay, I am applying three different moment. One moment is about z, and one is about x, and one is about y. Now tell me guys, what is this mz, what is this mx, and what is this my? So which is torsion? Everybody, which is torsion? Mz is torsion. Okay. So the moment which is acting about what? The moment which is acting about what? Acting about what? Longitudinal axis. The moment which is acting about longitudinal axis, Mz is what? Torsion, right? or torque? Torsional load or torque. Okay. So mz is what? Torsional load or torque. What about this mx and my? What about mx and my? Mx and my are bending moment. So now guys, tell me, what is the bending moment? What is the bending moment? The bending moment always act about what? Which kind of axis it acts? The bending moment always act about what? Acts about what? Cross sectional axis. Clear to everyone now, guys? The basic difference between bending moment and torque. Both are moment or both are couple. Both occurs. I will tell eccentricity of the load part also. I'll tell, guys. Okay. Clear? Hmm? Clear, guys? Okay. Now, guys, to understand what I mean by eccentricity, okay. So let me draw again this part, and then we will go to question series. Okay. Okay. Now, guys, you look quickly here. If I draw this again, so guys, are you finding class interesting? Yes or no? Quickly can tell. Yes, can both occur at same time? Yes, Abhishek. Why not? Both can occur at the same time. See, I will tell you how both can occur at same time. Okay. So Abhishek or the others, look here. We have drawn. This is what cross section, right? And we have drawn. This is what longitudinal axis. Now, guys, suppose there is axial load. There is an axial load which is acting not through this centroid. Okay, or you can say origin. This is O point. I have one axial load which is not acting through O, but it is acting at some distance from O, and it is along what? Z direction. Now, guys, tell me what is going to happen? What is going to happen? Anyone? There is a eccentricity of the load, right? Due to this eccentricity of the load, what is going to happen? There will be a moment, and moment will be about which axis? If I draw this line, okay, or no, wait, guys. This line is like this. Uh, yeah, this is x-axis, and here this load is applied at this x-axis. So what it is going to do? Exactly, there will be axial loading and there will be a bending moment. So when you bring it, this load along Z, okay, it will be P load acting along with, there will be a moment, and moment will be what? About Y axis. The moment will be about Y axis. Clear? So what will be My? Your My will be P into this eccentricity. So clear, guys? Now, Mr. Abhishek, suppose it at this point, same point, at this P same point, I have another load which is in vertical direction, which is in vertical direction. Okay, what is going to happen? Tell me now, Abhishek. This is again eccentricity. This will twist, right? How? When we resolve this force or take along this origin, this P, and along with this will come with a twist about Z axis, right? You can say the twist will be in the this way. Okay, no, this, so that was the correct. Yes, so there is what mz, and that is also P into E. Clear? The same time you can have, right, same time you can have both twisting and bending. When suppose my this P load was acting at some angle in inclined, right? The load was not either axial or vertical, it was some inclined load. Clear? Right? So when load was inclined with your Z axis, that time there will be vertical component, then there is a axial component. Axial component will create bending and vertical component will create twisting. Are you all able to visualize, Mr. Ajay Krishna? Are you able to visualize this? Amit, Abhishek, Sanjeev, Shivani, Shivendra, Rujana, Vignesh, Vikas, Vipin, you all are able to. Guys, congratulations! Today India won, right? Handsomely. So you all, many of you might have watched the match, right? I was thinking people may not come, so they played well, right? And team is also good, right? Combination is very good now. Good all rounder, batting, bowling all rounder, spin all rounder. It was a good game. Like they have built a good team, especially Rahul Dravid. He should, good bowlers, good batsmen. So that's good. So it's all hard work, right? Yeah, it was so early. They didn't play well, batting, especially Pakistan, right? Yeah. So that is on lighter note. So it's clear, right? You all are able to visualize how the twist is created. Even the, oh, is it? So sorry. We couldn't cancel class, but class is important, right? Specifically July batch. Every slot is important because deadline is December. So sorry. You guys can watch highlight later. Yeah. But the good thing, we won easily. Yeah. So guys, now till now, is it clear? How to visualize torque, how to visualize bending moment, how these are created due to eccentricity of the loads. Okay, and those things can be at the same time all. So that's all about bending moment and torque. Okay, now guys, next thing, tell me guys, what is buckling? I'm just revising these basics because you all have completed that. Yeah, angle part. Yeah, Vignesh, sure. So, Vignesh, if you see this 2D, let's understand with 2D. This can be vertical load, this can be horizontal load, right? Now, suppose my load is acting like this, neither horizontal nor vertical. What is going to happen? There will be a horizontal component and there will be a vertical component. Now these loads are supposed at some eccentricity from O. Both load will create respective moment. Clear? This angle part? Ravi, is it clear? Abhishek, everybody? No, 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 no. Ravi, it is not Sam. We'll do that in unsymmetrical loading. You cannot resolve moment just like load. Okay, moment resolution. If moment is acting about axis, moment is acting in a plane, all those things we will do in unsymmetrical bending. Okay, sign convention and all. When moment will be, that's different story. It's very complicated actually. Okay, it's not that simple bending. Okay, failure of beam under compression loading is no, it's not buckling. What is the buckling? Deflection in transverse direction due to axial compressive load for shorter column? No. What is actually buckling? Guys, do you think column buckle due to load? Dinesh, sorry, Pranita, can answer column buckles due to applied load? Anyone? Sahil, do you think column buckle due to applied load? You guys have learned now stability of column. Sir, I have taught, right? So is it column failure is a material failure? Renita, is column is a material failure or column buckle due to applied load? No, none of you are correct. Guys, first thing understand. Buckling failure is not due to material or applied load. Okay, you guys must read Gare book properly. The buckling failure is a failure due to stability. What stability means? My column will not fail until unless due to external disturbance. Okay, only the load play with the condition. Okay, what is the condition? Suppose I have a long slender structure, okay, and it is subjected to some load P. Okay, now what is going to happen, guys? If my P is greater than P critical, right? P critical is what your buckling load. If my P is greater than P critical, and if there is some kind of very small disturbance theta, you know the disturbance, what is the external disturbance? Can anyone tell, Balaji or Chanabasaya? What is the external disturbance? In building, you see, right? Sometimes building get collapsed under what? Heavy wind, right? So if your compressive load is greater than P critical, and if there is any external disturbance theta, okay, either due to wind or any other thing, what is going to happen? What is going to happen? This theta will what? Will get what? Increased, right? It will get increased. Why? You all have learned, right? Stability of column. Suppose my column is, okay, disturbed by some angle theta, right? So what is going to happen? It got disturbed by theta. Now what is going to happen? If P is greater than P critical, what is going to happen, guys? Your distorting moment. What will be your distorting moment? My distorting moment will be P into L theta, right? What is the distorting moment? Means it will try to rotate in the same direction. What is the restoring moment, guys? What is the restoring moment? Suppose my stiffness of this column is idealized with what? A spring, right? So K is what? My stiffness. So what will be the spring force? It will be K into L theta. Okay, so what will be my restoring moment? It will be KL square theta, right? Now, guys, what happened? When P is greater than P critical, the column will be unstable. Okay, the column will be unstable for any small disturbance. The disturbance will keep increasing and column will collapse. So that is what the failure, buckling failure. It will try to regain its original position. Only if what? When it is try to regain, if Rm greater than what? Dm. And when is Rm greater than Dm, can you tell? If your KL greater than what? P. So if your load is less than P critical, then only it is a stable equilibrium. Or you guys might have learned this in equilibrium. There is one plot. What is that plot? There is a plot between theta and load, right? Theta and load, right? This point is what? This point is known as what? P critical, right? Bifurcation point. It is known as bifurcation point. So 0 to P critical, this equilibrium is known as what? This equilibrium is known as what, guys? Can anyone tell? What kind of equilibrium? Stable equilibrium, right? When P equal to P critical, what it is known? Neutral equilibrium. And when P greater than P critical, what it is? Unstable. I am not teaching this column in depth. But now, guys, are you clear? The buckling failure is not a material failure, neither it is due to or neither it is a strength failure, neither it is due to load, or it is due to what? The deflection caused due to load. That is what bending you call na, ki the bending is happening. It's not due to material or strength failure, it is due to some external disturbance. Clear, guys? If there is no external disturbance, the column will be what? Will column collapse without disturbance? If your P greater than P critical, it will not collapse until unless there is an external disturbance. Okay, so my the whole point was to explain you guys what actually buckling is not a strength failure or not a material failure. It is a failure due to external disturbances under critical load. Okay, so your structure need to be designed for safe buckling load. Okay, you cannot have a load, a compressive load which is more than P buckling strength. Okay. Yes. No. Actually, buckling is not depending, but critical buckling load it depends na the kind, because what is the critical? Simple Euler buckling formula. It is pi square EI by L square, right? This is what? Simple buckling formula. Clear? Yes or no? So here it depends na. E is there na. critical buckling load will, so actually what now this is something known as buckling allowable, you know, right? What is this critical buckling load known as? Everybody, this critical buckling load is known as what? Buckling allowable, right? So we use this word buckling allowable. Okay, it's not material allowable, it's buckling allowable load. Okay, so axial stiffness means what? Again, it depends on materials and cross sectional property, right? So stiffness is also function of material properties. Just a moment, guys. Okay, so clear, guys. This is clear. Now, guys, the last question. Okay, in this session, recap. Now, guys, tell me what is the limit load? What is the ultimate load in aircraft design or in aerostructure design? What is the limit load? This is another interview question. What is the limit load? If you go anywhere in interview, so limit load is a load which can any structure subjected to only once in a lifetime, okay, of the structure. Yes, the load up to yield point, but yielding is not allowed, Abhishek. In any aerostructure, yielding is not allowed. You cannot have a plastic strand. So limit load is what? A load which can be acted only once in a service life of the structure. Okay, that is what? Limit load. What is the ultimate load? No, it is not factor of safety. Ultimate load is always in aircraft industry. It is 1.5 times of the limit load. Why this ultimate load concepts comes in picture? To avoid catastrophic failure. You know, right? Due to gust or due to emergency, that should not be failure, right? See, if your car, if you are driving and something happened, you can stop, right? But something happened in aircraft, you want to get it crashed? No, right? So always aircraft also designed for ultimate load. For ultimate load, there can be plastic strain or there can be yielding, but it should not have a catastrophic failure. Okay, so your design need to be safe also for ultimate load. Usually ultimate loads are 1.5 times of limit load. So in aircraft industry, the limit load is defined as what? The maximum load that an aircraft is expected to see at any point in service life of that aircraft, only once. Okay, whenever it, if load is reached to limit load, then that component needs to be changed. Okay, if any component subjected to limit load at any time, then that has to be changed. Okay, so this is what? Limit load. Now you guys can read this theory part, I will provide this. Okay, so guys, what is the ultimate load? It is always 1.5 times of the limit load. And of course all the certification are done for limit load first and then ultimate load as well. In ultimate also there are different kind of loads. Have you guys have heard about this FBO, fan blade outing, bird ingestion, fan blade out, Or have you guys heard about this one engine failure? What they called this kind of I have done all different kind of analysis when I was working in different aircraft industries for different scenarios. Okay, yeah, one engine failure. So what they call it as there will be disbalancing of the load, the heavy disbalancing will be there. So they call it as now, it's long. I have to recall or uh, I need to recall those terminology. Okay, but FBO, bud ingestion, all these are common failures. See, if you use limit load analysis, then allowable will be limit allowable, Mr. Abhishek. They use the materials, there are handbooks, okay, material handbooks. Anyone remember that material handbook name? If anybody have worked, that is called MMT, what is that? MMPS, MMPS. I think MMPS. There is material allowable books. Yeah. Okay. MMPDS they call. I think MMPDS. That is the standard material allowable books in aircraft industry. So using MMPDS, you will find the allowable, limit allowable, and ultimate allowable, Mr. Abhishek. Okay, and even your limit allowable for compressive under compression and tension will be different. Always compressive allowable will be higher than tensile allowable. Okay, so all those are there. So this you guys can read. Now there was one more thing. There are around 50 question. So guys, should I do or can do this basic question? I thought to recap. So you guys can do, right? This almost recap your whole SOM part, mainly your theoretical part. Some there are 51 questions I have listed. Okay, so let's do few question because no, I will now itself I will share you guys. Should I do or you guys can do on own? Okay, I want to check. So stress and strain are what kind of quantities? Yeah, bird strike is bird ingestion. Yes, Sivendra. Bird ingestion is a bird strike. And there are testing also done for bird ingestion. You know what they do in thrust belt? They will put a mass. They will throw the mass. There are testing also done. Okay, on thrust belt for bird ingestion. That is a very normal problem, right? Many time aircraft when fly this bird ingestion. Yeah, chicken. In YouTube you can see those videos also. Okay. FBO is also there. Fan blade outing events. Yeah. So when you come in aircraft industry, either in aero engine or if you work in aircraft airframe structure, mainly in aero engine, lot of analysis are done for different ultimate condition. Okay. Same way for ultimate loads, G loads. One more question I didn't ask. In any structure, what are in a broader way, what are kind of loads acts? What two different kind of loads acts in a broader way? Can you define the loads on a body on a broader picture? Can anyone define in a broader way loads on a body? Can anyone define loads on a body? Mm-hmm. What, Sivendra? What distributed and point load? See, on a body, only two kind of load acts. One is what? Body forces, and second is surface forces. Clear? Only two kind of loads acts on a body. One is body force, and one is surface forces. So, what is the body forces? Forces due to gravity. And what are the surface forces? The surface forces what? The forces due to air, right? Or you can say shear or normal forces, pressure and shear. Exactly. Now somebody will tell, like what? Somebody will tell torsional load, bending, all these comes from where? Where from where you derive your bending loads, torsional load, axial load? From where you derive? Anand, Ajay, from where you derive? Ishaq, you derive all those loads from this only, from body forces and surface forces. You guys have heard about CFD analysis? What in CFD people do? They will in CFD. What kind of load people apply on a body? They apply only body forces and surface forces. They analyze what CP and CF you are telling, Devendra. See, the CFD team basically what they told, they in aircraft industry there is something called load team. So in load team, they will apply body forces and surface forces on an aircraft, and then they will find loads at different section. So loads are calculated in terms of what? In terms of forces and moments. So at every section, what is the moment loads? What is the force components? Okay, clear now? So on a body, on a broader way, you can define loads only in two form: body forces and surface forces. Body forces are due to gravity, and surface forces are like pressure and shear. Clear now? Is there directly bending bending force acts, bending load acts or torsion acts on a body if it is flying in a air? Suppose your aircraft is flying in a air, will that directly you call transverse load is acting? What is the transverse load? Lift. What is actual lift? The lift is the pressure difference, right? What actually lift? It is a force due to pressure difference, right? So it is, yeah, surface force. Okay, it's a surface force due to pressure difference, right? Between upper and lower surface, right? Okay, now, so that is, guys, also again, it's very important, okay, to understand the load in a broader way. Okay, clear. Now, the next, stress at a point can have how many components? How many components? Why people are answering D and A? Who is answering D and A? Ashish, at a point, how many components you will have? Hmm? So how many components we can have? Huh? It's not about Hooke's law. Why, Chanabasa, you are bringing Hooke's law? You have read na that is a three-dimensional stress system. There are total nine components, right? Out of nine, how many independent? The six will be independent stress component. Nine components are what? Sigma xx, sigma yy, sigma zz, then tau xy, tau yx, then tau zx, tau xz, then tau yz, and then tau zy, right? So these are six. Okay. Now how many independent? So independent is 6, right? Why? Because tau xy equal to tau yx, tau yz equal to tau zy, and tau zx equal to tau xz, right? So 6 independent. Now fourth, for 3D body under thermal loading, how many independent stress components are under thermal loading? How many independent stress components? Huh? Only thermal loading. Zero. What zero? Chanabasa. Independent stress components under 3D body under thermal loading. We have not told here specifically. There is constant. I am considering there are constants, right? There will be some constants, right? No, no stress will be there if there is no constant. Okay, so these questions need to be, have better wording. Usually, there will be three stress components if it is restrained in all three direction. Okay. Now, tell me what those three stress component: normal or shear. Thermal loading will not create any shear. It will only change the volume. So it will have only normal stress component. Now question number 5. Shear stresses are of what kind of nature? Same, opposite. Shear stresses are of complementary nature on two perpendicular planes at a point in a body. Okay, complementary nature. So we have done these first five questions. I am now sharing this file with you guys. You guys do all these question. Okay, you guys do this question as a practice and before tomorrow's class. Okay. So I am sharing this in chat. You guys can download from chat once it is available. So how was the class, guys? Was it different than previous classes? Was it useful? Yeah, anyway, I'll share in WhatsApp also. Okay, not to worry. So don't worry, guys. I will make sure my classes are always interactive. I can't teach without response. Okay, but I want like the my content should be different. Yeah, always like That's see my personal way. It is not like I will be keep talking with the people, okay, while class. So thank you guys, because this year I'm taking first class, okay. Fortunately, like now I'm not getting that much time to teach, but down the line I want to teach actually, because strength of material, thin wall structure, mechanical vibration, I used to teach, okay. And now I have very good supportive hand, that graphics guy, so he can create proper questions and all for me. So I should teach more, but always I'm more involved in organization. So that's why. So Rahul sir also teaches well, right? Of course, um, he also teach very well. So that's why I just took this session. I can give further picture where you guys should improve. Okay. Sivendra Raj, we need to create app, right? Sivendra Raj, like, yeah, of course we will improve. But website is good option, right? Because app means many times people find like they are able to log in mobile only. That's another disadvantage with app. Many app based, learning tool have that disadvantage. But we will have both, app which is supportive on desktop as well as mobile, so that will be the way forward, okay. But before that, yeah, I'm ready to hire people, but I'm not finding right people to hire.